Okay, now I'm going to try a quick video on trigonometry. Right, so for trigonometry is to do with your triangles and their areas and their lengths of lines and angles of lines and stuff like that. Let's see if I can focus this any better. It's probably worse, isn't it? Okay. Right. The paper I'm showing you at the moment is 2015 paper 2 question 5. On the picture it has given you a typical trigonometric drawing, right? They've told you it's made up of two triangles, the triangle BCD, so B going to C to D, so that's that triangle, and the triangle ADB, which is the larger of the two. Okay? In terms of questions, the questions asked you to find the length of a particular line, the area of a triangle, and the length of a different line. Okay? So the first line it had asked you to find is BC. So BC is the line going from B to C. All right? If I move this over so you can see your picture. So we are looking for this line. So in terms of this line, you look at the picture and you go, okay, which triangle is it attached to? So it is attached to the smaller of my two triangles. So if you do a quick sketch, you have that. Okay, D's in the corner, C's up here, and B's down there. You are looking for this side, so we're going to call it X. Okay, I should really move it over so you can see what I'm waffling at. Okay, in terms of this triangle, we know that this angle is 110, this angle is 42. So before you start, make sure you've labeled everything on your triangle. So we know that we have these two angles. So the question is there any way you can work out the angle of the third? Right, the way you work it out is you will have this angle is equal to 180, which is all your angles in the triangle, take away the other two. So when we add up the other two, we get 152 degrees. So if we go 180, take away 152, you are getting 28 degrees, right? So that means this triangle has 28 degrees at the bottom. Right? So now, back to the original question, we are looking for the length from B to C, so this side. So in this triangle. So in terms of trigonometry, questions I ask myself, I go, what type of triangle have I got? Have I got a right angle triangle? So when I look at that triangle, I do not have a right angle triangle. Right? So it's not a right angle triangle. And I would write that down. Not right angled triangle. Right? Because it's not a right angle triangle, there's lots of things I can't do. Right? So you sort of go, what are your options? So your next option is the sine rule. Right? For your sine rule, you have to have two things. You have to have the length of one side and the size of its opposite angle. So when we're looking at this triangle, do I know the lengths of any of the sides? When I'm looking here, I go, no. So I look back at my picture and I go, aha, I forgot to label part of it. So now I do. I have a length of a side and an opposite angle. So because I have those two, so on the big picture I have this and I have this. So a length of a side, its opposite angle. Because I have those two, I can use the sine rule. Because I'm looking for a length, I put my length on top. So I go x over the sine of its opposite angle. So the angle that would be across from this side, so the angle not touching this side in this triangle is 42 degrees. So we go x over sine 42 equals the side we know, which is 16, over the sine of its opposite angle. So the angle not touching it. Okay, so you plug that all in. We don't want x divided by sine x, we just want x. So x is equal to 16 sine 42 all over sine 110. When you have that, you get your calculator. You put your calculator back into normal mode by pressing 1 if it's not there. You check it says degrees at the top and then you plug it in. So you go 16 sin 42 equals divided by sin 110. close your bracket, press equals, and you get 11.393. So the length of that line is 11.393. Now in the question it asks to give it correct to 2 decimal places. So you look at the third decimal place. If it is a 5, 6, 7, 8, 9, you add 1 to the number in front. This is a 3, so I just leave it as 11.39. When I have that done, I then label it onto my original picture because I might need this to do the next part. The next part, it says find the area of a triangle. All right, and the triangle we want is BCD. So again, the little one at the top. To find the area of the triangle, we can either use half the base by the perpendicular height. So half base times perp height, right? Or you can use half AB sine C. All right, so for half the base by the perpendicular height, I have not got a perpendicular height for this triangle because I have got no 90 degrees. Okay, so instead I'm going to use this rule, my half AB sine C rule. This translates into half the length of a side, sine of the angle in between. So when I'm looking at this triangle, I have the length of a side, I have the length of another side, but I want the angle in between them. So that's why it was really important I'd worked out my 28 degrees earlier. If I wanted to use 42 degrees, I would have had to work out the length of this side. If I wanted to use 110, I would have also had to work out the length of this side. So your half AB sine C means the half of 2 sides, sine of the angle in between. So in terms of this triangle, I'm going to use this side, and the angle in between. So I go half 11.39, 16 sine 28. Right, so I plug them into my calculator. So 11.39 times 16 times sine 28 equals, and divide it all by 2. And I get the area is equal to 42.778. Again, this question asks correct to 2 decimal places. So I look at the third decimal place. This is an 8, so that means I have to add 1 onto the number before. So I'm getting 42.78 when I round it to 2 decimal places. The third part of this sum asks you to find AB, the length of AB, correct to 2 decimal places. So AB, back to our original triangle, AB is this side. Okay, so you look and you go, it's on this triangle. In terms of this triangle, you go, is that triangle a right angle triangle? The answer is no. Okay. Is there any angles you can work out for it? You can work out this angle. So this angle is 180 because your whole triangle is 180, or your whole straight line is 180. Take away 63 and 42, which makes 105. So that angle is 75 degrees. I can't find this, I can't find this. Right? So to find my AB, I go, okay, do I have a right angle triangle? The answer is no. Can I use the sine rule? Do I have a side and its opposite angle? The answer also is no. So what I am left to do is I get to use the cosine rule. So your cosine rule. Your cosine rule is a squared equals b squared and c squared minus 2bc cos a. So your a and your a have to be across from each other. So one is the length and one is the angle. So in terms of this, we are looking for AB. So if I move it back down so you can see my triangle, AB is here. So the angle across from it is that, it's 75. So when I match them in, I go, I don't know what that is, so call it x squared equals 16 squared 10 squared, they're my other two sides from the triangle, minus 2, 16, 10 cos of 75. And then I plug them all into the calculator and get the square root. So 16 squared plus 10 squared minus 2 bracket 16 bracket 10 cos 75 close bracket equals grand total of 273, right, 0.177, and then I want the square root of it. So if I press the square root, it gives me an error. So the square root of 273.177 gives me 16.528. So again, look at the third value. It's bigger than 5, so add 1 on. So my answer for that is 16.53. So the length from A to B was 16.53. Hope that helped you.